By the end of this lesson, you should be able to describe what a probability distribution is, making sure that distribution is valid, draw a histogram of the distribution, and then use it to find the probability of certain events. First, I'm going to talk about a random variable and probability. A random variable is a variable whose value is a numerical outcome of an event. So if we're talking about the grade distributions, like you see on the right, we talk about A being a 5, B being 4, C3, C3, I was about to say C3PO, C3, D2, and F equals a 1. So we gave them numeric values, and then underneath it is the number of students who have that. So we say that X is a random variable, that is just a number assigned to an event. Okay, so the event of getting an A would be a 5. The event of getting a B would be 4. Underneath that is the number of students who, or number of occurrences of that event. All right, so we're going to use that table to find the probabilities of the things they ask us for. So for instance, find the probability that a randomly selected student in this class received a grade of C. So first we need to figure out the total number of students. I'm going to add that up. So let's see, 6 plus 9 plus 5 plus 4 plus 1 would be 10 plus 15, which is 25 students. Okay. Find the probability that a randomly selected student in this class received a grade of a C. So if we look, C they said was 3. So here's my C's. And there's 5 students. So 5 out of the 25 students got a C. So if randomly selected, it would be 5 out of 5. Now we're talking about probability distributions, and we'll talk about a normal distribution as well. We tend to write our probabilities as decimals. So for this lesson, we're going to write our probabilities as decimals. So 5 divided by 25 is 0.2. Find the probability that a randomly selected student in this class received a grade lower than C. So that would be students who got a D or an F. So there's 5 of those. 4 got a D, and 1 got an F. So again, 5 divided by 5 would be 0.2. If you notice, that would also represent 20% because you move the decimal 2 places, right? So 20% of students got a grade lower than a C. What is the probability that a randomly selected student in the class passes the course, that is, gets at least a D? So there's 2 ways of doing this. We can say, hey, just count up the students had A's, B's, C's, or D's. But I find it easier to say, hey, one student got an F, so that means 24 got, did not get an F, did not fail. So 24 out of 25, or 0.96, or that's 96% of the class. All right, so again, a random variable is just when we put a number to an event. Okay, and then we talk about the number of occurrences of that event. The table shows the results of tossing 3 coins 50 times. What is the probability of getting 2 or 3 heads? So this time our random variable is the number of heads that we got. So if I'm throwing 3 coins in the air, the times that I had no heads was 6, 1 head was 20, 2 of them was 19, and then 5 times all 3 of them were heads. So what is the probability of getting 2 or 3 heads? So we know that the number of times should add up to 50 because we did it 50 times. And it does. 6 plus 20 plus 19 plus 5 is 50. All right. What is the probability of getting 2 or 3 heads? So that'd be 19 plus 5. All right, so 19 when we got 2, 5 when we got 3. So it'd be 24 out of 50, which is 0.48, or 48%. So we can make a table of the events. All right, we can use that to find some percentages. Okay, and again, the random variable is just putting a number basically to outcomes. Probability distributions. So, probabilities associated with every possible value the random variable x make up is called your probability distribution for that variable. So here are the properties of that. The probability of each value has to be 0 or more, so either it doesn't happen or it happens more than once. And all the probabilities have to add up to 1. So a probability distribution is a way of showing how the probability of that event happened. Okay, so I say, okay, what's the probability of, if I was going to do like a probability of getting heads or tails. Okay, so let's say 1 is getting heads, 2 is getting tails. We would say about 50% of the time we're getting heads and about 50% of the time we're getting tails. Notice that both of those have a value that's greater than or equal to 0. So I have a probability of 0.5 for one and 0.5 the other. Those add up to 1. 0.5 plus 0.5 is 1. And you can graph it. You can say, hey, 1 being heads, 2 being tails. We'll say, all right, here's a probability of 0.5. There's the graph of it. Okay? So it's a probability distribution is just how is the probability distributed to the different events that can occur. All right, so, and when you make the graph, it's called a probability histogram. So let's look at this probability distribution. The table at right shows the probability distribution for students by enrollment in the United States in the year 2000. Okay, so if I talked about a bunch of students, the probability that that student would be, or if I randomly, I guess, talk to a student, the probability that student would be in elementary school is 0.562. The probability that student would be in secondary school, which normally is called high school, we call it high school, is 0.215, and that if they were in college or higher education would be 0.223. So being in elementary has a higher probability of being in secondary or higher education. Okay, so X is the type of school, and that's our random variable. We assigned it 1 for elementary, 2 for secondary, 3 for higher education. And then in the other column is the probability of those things happen. So first we're going to say that they're valid. So we know it's valid because 1, all of the probabilities are 0 or higher. There's no negative probabilities. And that we want to make sure that all those probabilities add up to 1, okay? Because the probability of getting, if I talk to a student, of that student being in elementary, secondary, or higher ed should be 100%, since those are the type of kids I talk to. All right, and when I add those, I do get 1, okay? So if I add up all those probabilities, I get 1. So for instance, 0.5 heads plus 0.5 tails equals a probability of 1. If a student's chosen at random, what is the probability that the student is in elementary or secondary? So those are mutually exclusive like we talked before. All right, so we would add those two things together. So the probability that they're one or the other. There's a probability that the student would be in secondary plus the probability that the student would be in elementary plus the probability that the student would be in secondary. And if I add those two things together, it's 0.777, or almost 78% of students are either in elementary or secondary ed. Now we're going to make a probability histogram. So 1, 2, and 3 are the type of schools. So remember, 1 is elementary, and that's the probability of getting that is 0.562. All right, or almost 56%. Okay, again, we're writing probabilities as decimals when we talk about the distributions. It's because the reason why they do that is because we're kind of making a switch towards probability getting kind of joining with statistics. In statistics, we tend to use decimals. All right, so that would be, let's see, number 1 would be about 562. That's about here. Okay. Should have used the marker one here. I'm going to. Okay, that's not a very good job. Next time I will not use the marker one. All right, 2 would be 215. So about here. And then finally 3, a little bit higher than that. Just slightly higher. All right. So there's your probability distribution histogram. So the probability histogram. So again, the probability distribution is just it tells you the probability of each thing occurring. It should have to 1 because it should be 100% probability that at least one of those things happening. All right. And if we want to know the probability of like more than one of those things happening, you would add together. For the spinner shown is spun twice. Write the sample space with all the possible outcomes. So all that means when they say the sample space of all the possible outcomes is kind of like if you said, okay, just tell me every possible thing that could happen. So when I spun the first time, my first one could be blue. Okay, so the first time it could be blue. Then I could get another blue. I could do blue, and the next time it'd be yellow. And I'm going to have to write a little bit smaller for this. The next time it would be yellow. Blue, and the next time red. Blue, and the next time I spin it, it could be white. Blue, and the next time I can spin it, would be green. Okay, so that's every possibility if the first one's blue. And it's kind of like those trees we did. So blue, and then you would say blue, blue, red. Okay, so those little trees we made. All right. Then the next time, let's say the first one's yellow. And the next one could be blue, yellow, and then yellow, yellow, and then red, yellow, and then white, yellow, and then green. Then my first one would be red, and then blue, red, and yellow, red, and red, red, and white, red, and green. Then my first one could be white, and then blue, white and yellow, white, then, that's not right, white then blue, white then yellow, white then red, white and then white, white and then green. And then finally, it could be green and then blue, green and then yellow, green and then red, green and white, and then green and green. So those are all the different possibilities if I spin it twice. So I spin it, and I could get yellow, spin it again, then maybe green. So all the different choices of possible outcomes could be here. All right, so now we're going to do the probability distribution for the number of times the spinner lands on blue. So X is our random variable, and it represents the number of times the spinner lands on blue. Okay, so we know we want the probability that it never lands on blue, that it lands on blue once, lands on blue twice. So never blue, blue once, blue twice. Okay, so first of all, we got to pick how many total possible events there are. Okay, or possible outcomes. Excuse me, possible outcomes. So let's see, 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10, 15, 20, 25. All right, so there's 25 different possible outcomes. All right, so we want to do the probability that X is 0. All right. And I think I left off the table here, but we can do that. All right, so probably the X is 0. So probably that it's never blue. So let's see. 1, yellow, yellow, that's 1. Yellow, red, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times that I didn't get a blue at all out of 25. Which, when I do 16 divided by 4, it's 0.64, so about 64% of the time. Now I want to do the probability that I got just one blue. So let's see. 1, 2, 3, 4, 5, 6, 7, 8. Right, and again, I should probably color code this. So the probability of not getting blue, if I mark those in red. All right, so like this is not blue, this is not blue, this is not blue, no blue, no blue, no blue, no blue, no blue. And notice there's 16 of those. Okay, 16 times I never got them blue. 8 times I got blue once. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 25 was 0.32. And then finally, what's the probability that I get blue twice? And that's just the one time. All right? So 1 out of 25, which is 0.04. And we should make sure that those add up to 1. So we're going to do 0.64 plus 32 plus 32 is 0.96 plus 0.04 is 1. Okay, so good. Those added up to 1. Because again, that's 100% of the time. So it's 100% of the time that I'm either going to get a blue not at all, blue once, or blue twice. All right, so we're going to make a probability histogram of the data. And for some reason, I didn't put that over here in the notes, but I will, I don't think it's on the next slide, but so let's just copy that over here. All right, this is the probability of X. This is 0. We'll put 0.2, 0.4, 0.6, 0.8, all right, and then 0, 1, or 2, and then X equals the number of times the spinner turned blue, okay, so 0, 1, or 2, number of times landed on blue. Again, this should be on your sheet that you're looking at, but I accidentally didn't copy it over. Okay, so 0.64 was for 0, so that's about here. 0.32, that's for 1, that goes here. And then finally 0.04, that's really slim right here. Okay, so there's the histogram of your probability distribution. Okay, so it's kind of to visualize, hey, there's more of a chance that I never get blue than getting blue. Okay, so I said, hey, what's the probability of getting blue once? 0.32. What's the probability of at least getting it once? So 1 or 2, that would be 0.36, because I would ask 0.32 plus 0.04. Okay. Oh, all right, let's do another one. Okay. So this is another probability distribution. Use the table that shows the probability distribution of the number of telephones per student's household at Wilson High. So this is the number of telephones in each home. So 1 would be just 0.01, the probability of that, so it's a low percent, 1%. Probability of 2 is 16%. Probability of 3 is 0.34, or 34%. Probability of having 4 phones in the home is 0.39, and then more than 5 is 0.10. Show that the distribution is valid. So first of all, they're all bigger than 0, that's good. Let's make sure they add up to 1. 0.34 plus 0.39 plus 0.10. 16 plus 34 is 50. 49 plus another one is another 50. Yep, they add up to 1. If a student is chosen at random, what is the probability that there are 3 or more phones in their home? So 3 or more, so here's for 3. More than that would be also the 4, and then more than that would also be the 5. And when I add all those together, it's 0.49, or almost 50% of students. make a probability histogram of the data. All right, so for number 1, we're really small at 0.1 or 0.01. 2, we're above this, so about here, a little bit more actually. For number 3, we're all the way above 0.34, and then even higher for 4, and then for 5, we're all the way back down to here. All right, so that's the probability distribution for that. So now you guys are going to finish, you're going to do 1 through 7. That's not too bad, not too many questions. All right.